In this lesson, we are talking about annuities. An annuity is a series of equal investments or payments at regular time periods. So examples of annuities would include mortgages, car payments, student loan payments, savings plans, any situation where you are paying down a certain amount of debt at regular time intervals or investing equal amounts of money at equal time intervals. So while we complete this lesson, it would be helpful for you to have the graphing calculator instructions handy. In particular, you will want to refer to those when you're completing your homework questions. And obviously, you will need to have the graphing calculator as well. There is one that you could download from the website if you're not listening to the lesson at school. So when we are calculating the amount of an annuity after a certain time period, or the length of time it will take, for example, to pay down a loan or things like that, the situation is a little bit more complicated because you're making payments or equal investments at regular time periods, as opposed to just investing one lump sum of money and letting it sit in an investment for a period of time, in which case we could just use our simple or compound interest formulas. But it becomes a little more complicated when you are continually putting money into that investment or continually paying money down on the loan. So for that reason, we're going to use technology in this part of your unit. And in particular, we're going to use the TVM solver on the graphing calculators. So at this point, turn on your graphing calculator. And to get into the TVM solver, press Apps 1, 1. And then on your screen, you should see the list of variables appear that match the ones that we have here on your note. So the first example we're looking at says, how much would you have to save monthly starting now to have $1 million by the time you retire? Assume the interest rate is 7% per year, compounded monthly. Now, the answer to this question may vary slightly depending on the age you are now, and you probably are not all exactly the same age. So just for the purposes of this lesson, we're going to assume that you are 17 now, because I think many of you probably are. Okay, so we'll assume that you're 17 and you want to retire when you're 55 and you want to have $1 million. So the question is, how much would you have to start saving every month in order to make that happen? Now, when you're working with the TVM solver, N refers to the number of payments. So in this case, we're talking about a monthly payment. So that would be 12 payments a year. And if we're going to do that from the time we're 17 until we're 55, that would be 38 years. So monthly for 38 years. Now, the nice thing about this application on the calculator is you can actually just type it in as 38 years times 12 months a year, and it will do the calculation for you right within the TVM solver. So you don't need to calculate that separately. Then when you scroll down to interest rate, it will perform that multiplication for you. Now, the interest rate gets entered as it is, not changed to a decimal. So our interest rate is 7. And the present value will be 0 because currently we don't have any money in our savings account. And just leave payment at 0 for a moment and scroll down to future value. Now the future value is how much you want to end up with. So that would be $1 million. And we're going to make monthly payments. So our payments per year will be 12. And our compounding period, since we're compounding monthly, will also be 12. The payments per year and compounding periods per year often match, but not always. Okay, and then this last line refers to whether you will be making your payment or investment at the end of the month or beginning, and normally we set that at the end of the month unless it says otherwise. Okay, once you've entered all of those values, scroll up to payment once again and press alpha, enter. And we should see a payment of $442.38, meaning we would have to save $442.38 monthly starting now until we're 55. Now, note that the reason the payment value comes up as a negative is because that's money that you would be paying out of your pocket, basically, to put into this savings. So it comes up as a negative value anytime it's money that you are actually paying out of pocket. Okay, moving on. Let's say then that we're going to work an extra 5 years. So we're going to retire at age 60. So then our N value, that would add another 5 years on to our working life. So that would be 43 years times 12 months a year. Still 7%, still starting at 0, still trying to save $1 million, and none of these values here change either. Okay, scroll up to payment once again, press alpha, enter, and now you'll see the payment has reduced down to $305, and 24 cents. And if we work 5 years longer than that and say we're going to retire at 65, that would be working for 48 years and making monthly savings payments. So 7%, present value is 0, still saving $1 million. And now we'll see that our payment goes down to $212.05. So you can see that the longer you work, obviously, the less you would have to save monthly in order to have the same amount at retirement, because you would be saving it over a much longer period of time. Okay, moving on. Our next example says, how much will those student loans really cost me? One of my favorite examples. So, student loans are another reality for many students who go off to college or university. And it's important when you borrow money for any purpose, but including to go to school, that you think about the interest that you're going to be paying on that money. And sometimes that will make you a little more careful in how quickly you spend that money that has been loaned to you. So the amortization period for student loans is typically 15 years. Now by that, just to jog your memory from last year, amortization period means the length of time it's going to take you to pay back a loan. So by that we mean that typically the government sets that as 15 years as the default. Now you can pay them off faster, but the default amortization period is 15 years. So suppose you borrow a total of $20,000 and the interest rate is 7.5% compounded monthly. And we want to calculate the monthly payment. So in that case, the value for N would be 15 years monthly. And the interest rate is 7.5%. Our present value now, since this is a loan, the present value of the loan is $20,000. So let's just make a side note here that for loans, the future value is 0, meaning at the end of the loan you don't owe any money to the bank. But for investments, where you're saving your money, the present value is 0. So with an investment, you're starting at 0, working your way up to whatever value it is you're saving. With loans, it's the opposite. You start with what you've borrowed, and at the end, you deplete that down to nothing. So we can fill in future value then as 0. And once again, this is we're paying monthly, and we're compounding monthly. So both of those values are 12. And set the payment at the end of the month. All right, cursor up to payment, press alpha, enter. And we should find that the payment required is $185.40. Now it says calculate the amount you will have to repay. Well, if we have to make 180 payments, since that's what 15 times 12 is, of $185.40, that means we have to repay $33,372. Sorry, $33,372. Sorry, I should say. Okay, and then it says, how much interest would you pay? Well, interest is the difference between the amount you pay back to the bank and the amount you borrowed. So let's write that down. Interest would be the difference between amount repaid and the amount borrowed. So we just calculated the amount we repaid to be $33,372, and the amount we borrowed was $20,000. So the interest we paid back to the bank is $13,372. Now, bearing in mind that you only borrowed $20,000, that shows you that a significant amount of what you repay will be interest. That's more than half of what you borrowed that you're going to pay back in interest. Now, student loans, as well as any other kind of loan, is sometimes a necessary evil in life. Without them, we can't do the things we need to do, like go to school and buy houses and buy cars. But it is important to keep in mind that the faster you can pay down that money, the better. And in the case of student loans, we need not be wasting that money on unimportant things because it's very expensive to pay it back. Okay, moving on to your next example, saving for a major purchase. So in this example, it says if you deposit $300 per month into an account that pays 3.6% per year, compounded annually, how much will you have saved after 2 years? Okay, now in this case, it's not the payment we're calculating. We are actually finding the future value, the amount we would have after 2 years. So the TVM solver works the same regardless of which variable you're solving for. So the one you are looking for or trying to find, you set as 0 or leave it as 0. Fill in all the other ones and then use the alpha enter function to calculate the one that you need. So in this case, we are going to deposit monthly for 2 years. So that would be 24 payments. Our interest rate is 3.6. The present value, since this is an investment, would be 0. The payment we know this time, it's given in the question to be $300. So we're going to enter that as negative 300, being careful to use the negative key, not the subtraction. Now we're going to make monthly deposits, but the interest is being compounded annually. So our compounding periods per year is 1, and we're going to pay at the end of the month. Now, just be careful here. The calculator will try to default your compounding periods per year to match the payments per year, so you may have to override that, okay? And just be careful that it didn't change it back to a 12 on you. So if you find you're getting some wrong answers in your homework, sometimes that happens. So just be aware that you sometimes have to override that and say, no, I really do mean those two to be different, okay? Because they're so often the same that the calculator almost tries to force them to match, but they don't have to match, okay? So now you go up to future value, press alpha enter, and you should get a future value of $7,449.77. So if you saved $300 a month for 2 years at that given interest rate, at the end of that 2 years' time, that is how much you would have. All right, at this point, please refer to the second part of your video lesson.